This is the second half of section 7.3b. In the first section we just talked about the basic ideas of elimination, and today we're going to talk about elimination with two scalars. Remember, the scalar is the number in front of the equation that you're going to multiply each equation by. So as you look at our two equations here, we're trying to think of a number that both of these first two, or these second two coefficients on the y's or the x's, would go into. As I look at 2 and 3, I think of the numbers 6 and negative 6. So if I can have my two numbers be 6x and negative 6x, then when I add them up vertically, they'll drop out. So I'm going to multiply the first equation by 3 and the second equation by 2. That's going to give me two new equations with coefficients that are opposites. So 3 times negative 2 is negative 6x, 3 times 5y is 15y, remember to distribute, and 3 times 20 is 60. A very key idea is distributing to all three of those parts. 2 times the next equation becomes 6x minus 14y equals negative 52. I now look at this vertically and I add it up. The x's are dropping out, and we only have one y left, and 1y equals 8. Very simple to start with. Now I'm going to try to find the value of my x. To do that, I'm going to plug it into the first or second equation. I'm going to choose the second one just because it has negative 7y, and that will be easier to work out as we go through it. So I'm going to replace that y with an 8, and that's supposed to equal negative 26. So 3x minus 56 equals negative 26. To solve this, I'm going to add 56 to both sides. That gives me 3x equals 30. I divide both sides by 3. As you can see, x is going to be equal to 10. I now have my second answer to the problem. I do need to check it. Since I used the second equation to solve it, I'm going to use the first equation to check it. Negative 2 times x plus 5 times y equals 20. I put in my value of x of 10, my value of y of 8, and I check it. That's negative 20 plus 40 equals 20, and sure enough it does check. So this point where these two lines cross is the point 10, 8, and that's our answer. We now look at our second example, which says solve by any method. Well, as we look at these, this is not in standard form of all the x's and y's on one side of the equation, but instead this x value is all by itself on one side of the equation. And so I'm going to take that x value and use substitution. And wherever I see an x, I'm going to replace it with that value of 5y. So here's my second equation, and I've left a large space in a parentheses where the x used to be. And in place of that x, I'm going to replace it with the x value in the top equation. That value is 5y. That's called substitution. So now I multiply out. That's 10y minus 3y equals 7. So 7y equals 7. Divide both sides by 7, and y equals 1. Getting the second value of x is very easy. I'm going to use the top equation. 5 times 1 equals x. So x equals 5. Checking this in the other equation, 2 times x minus 3 times y equals 7. I'm going to plug in the values of x and y. X equals 5, y equals 1. So we have 10 minus 3 equals 7. And true enough, it does work. So once again, I write my answer as a point, 5, 1. So in review, the main ideas of this problem, we're looking at a consideration of two different scalars might sometimes be used, or substitution when the problem has a variable all by itself.